Good morning, everyone. Welcome back. We are covering Unit 8, Day 3 notes today, which is on the properties of logarithms. Just a quick set of notes for you this week. They all deal with ways to expand or condense logarithmic statements. And they're based on, because a logarithm is an inverse of an exponential, it is sort of the opposite of your exponent laws. So like when we multiply powers, we add our exponents. So our product rule for logarithms is that if we are multiplying two terms within a log, then we can separate them also with addition. Similarly, when we divide powers, we subtract our exponents. So if we divide terms within a logarithm that we're taking the logarithm of, then we can separate them with subtraction. That's called the quotient rule. When we raise a power to a power, we multiply our exponents. And sort of the same thing happens here. When we have a power within a logarithm, it's the same thing as multiplying by that power, by that exponent. And this will be helpful if you are a Casio graphing calculator user. If you don't use Desmos, most calculators will only calculate to a base of 10. There's no way to enter in a different base other than 10. So we have what's called the change of base rule, so that you can find the base or find the logarithm of bases besides 10. And you simply take the logarithm of whatever base you need. Like I said, in most cases, that would be 10 because that's all the calculator will do. And if you take the logarithm of whatever term it is, you would just divide it by the log of whatever base it is you have. So we have some examples over here real quickly. So normally this is something you would not be able to do directly in a calculator. You couldn't type in log of base 4 of 25 because your calculator will only calculate bases of log 10. But if we use our change of base formula, we can take log base 10 of 25 and divide it by log base 4 of 25, which is the same thing as taking the log base 4 of 25. So it's a real easy formula. If you use Desmos, Desmos has an option so that you can take the log of any base. So you can just kind of type it in. You'll see it's really easy. The log of base 2 of 12 would be log of 12 divided by log of 2. And remember, if there's no base written, we assume that it's a base 10. Okay, so let's see the other properties in action. So in example 2 here, they're asking you to write each logarithm in terms of natural log 2 and natural log 3. So 6 is the product of 2 and 3. So I could rewrite this as, or separate it out as, based on the product rule, the natural log of 2 plus the natural log of 3. And in letter B, we have the natural log of 2 over 27. So we can use the quotient rule to separate those two terms by subtraction. The natural log of 2 will stay because that's what they want us to do, but they want us to write 27 as some version of natural log 3. Well, 27 is 3 to the third power, so I can write it with natural log 3 to the third power and then use my power rule to put that 3 in front as a coefficient instead. And then the next question asks us to use the properties of logarithms to verify that negative log of 1 over 100 equals the log of 100. Well, remember, any coefficient will become a power. So a negative logarithm will become 1 over 100 to the negative 1 power. And a negative exponent just flips or takes the reciprocal. Remember, it does not make your term negative. So 1 over 100 to the negative 1 power would become the reciprocal of 1 over 100, which would just be 100. So now in example 3, we're going to do the opposite. We're going to go the other way. We're going to expand logarithms. So we have a lot going on here. We have the log of base 4 of 5x to the third y. So the first thing we want to do is separate it using the product rule. So we're multiplying 5 times x to the third times y. So I separate that out. I keep my base the same all the time. Any exponents, I want to apply my power rule. So in this case, where I have x to the third, that's going to become 3 log base 4 of x. And now this is as expanded as it will get. In this case, the first thing that we see is the quotient rule. So the first thing I do is I separate this using subtraction. And then remember, any radical can be written as an exponent that's a rational number, where the denominator is the root and the numerator is your power of your exponent. In this case, we're just taking the square root of 3x minus 5, so there is no exponent, so the exponent's 1. And because it's a square root, the denominator is 2. So 3x minus 5, the square root of that becomes 3x minus 5 to the 1/2 power. So again, that power rule becomes the coefficient, and you cannot separate subtraction or addition. Okay. There's no means for doing that. Similarly with exponents, remember, you cannot add powers and change the exponent. There's no mechanism for doing that because exponents are repeated multiplications. So addition and subtraction don't have rules for that. We don't have rules for that. Okay, and then finally, going backwards, we're condensing. And so we kind of just apply the rules in opposite. Any coefficients become powers, and any addition turns into multiplication. So again, in B, our coefficient became our power, and we have subtraction, so that now became division. This one's a little bit tricky because we have a lot going on. So on the outside, we have a 1/3. So the first thing I did is I kind of distributed that 1/3 to all of the terms inside. And then I see inside that I have addition, so that becomes product rule. And then the 1/3 on the outside becomes the exponent, and an exponent that's a rational number or a fraction becomes a radical of some sort. So because it's to the 1/3 power, it's a cube root with an exponent of 1. So the other way you could do this is condense the inside first to multiplication. So I could have first made this 1/3 on the outside, log of x times x minus 4, and then just done everything, taking the cube root of that. So whichever way feels most comfortable for you, either of those are mathematically correct. So there is some associated practice with this. It is titled Properties of Logarithms. There are a couple of pages of practice on that. And then there's this one interesting page called Writing Logs in Terms of Others. And that's kind of practice like in example 2, A and B up here. So give them a try. You don't have to do all the problems. Just try to maybe do a sampling of some where you have to expand, some where you have to condense. And we want to get good at that because our next lesson is going to be on solving logarithmic and exponential equations. And so we'll sometimes need to be able to use these properties to condense them down into something that we can solve. So let me know if you guys have any questions. We'll be having the optional help session on Wednesday at 2 as usual. And I will see you guys soon. Well, not see you, but you know what I mean.